This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Do you remember how to solve a system of two equations using elimination? We can manipulate one equation and then add the equations together in order to cancel or eliminate one of the variables. Then we can solve for both variables by substituting the value we solved for into one of the original equations. In this video, we're going to solve systems of equations in three variables using elimination. Let's get started with an example. We'll solve this system of equations for x, y, and z using elimination. This will be pretty similar to the process of solving a system of equations in two variables, but there are some key differences. First, we need to eliminate the same variable from all three equations. Looking at the three equations, I think it will be easiest to eliminate z first, since the first and third equations have z coefficients of 1 and -1. But technically, we could start with any variable. Now, we'll line up the first two equations here, and then we'll line up the second and third equations here. Note that we could have chosen another combination of equations to align, but we'll get the same result no matter what. Okay, so let's eliminate z from the two equations on the left. In order to do this, we'll multiply the entire top equation by 3. So the top equation becomes -9x minus 3y plus 3z equals 0. Now we'll add together the two equations. -9x plus -2x is -11x, -3y plus 2y is -1y, 3z plus -3z is 0z, and 0 plus -9 is -9. As you can see, we've eliminated the z terms and we're left with -11x minus 1y equals -9. We could just write this as -11x minus y equals -9, but let's leave the -1 in place for now, since it'll help us line things up later. Next, we'll eliminate z from the two equations on the right. This time, we'll multiply the entire bottom equation by -3. So the bottom equation becomes -6x minus 9y plus 3z equals -54. And again, we'll add together the two equations. -2x plus -6x equals -8x, 2y plus -9y equals -7y, -3z plus 3z equals 0z, and -9 plus -54 equals -63. Great, we've eliminated z from these equations as well, and we're left with -8x minus 7y equals -63. So now there are no z terms in either of our equations, and both equations have x terms and y terms. If we line these equations up, we can eliminate another variable. Let's work it out. We can multiply the entire top equation by -7, so the equation becomes 77x plus 7y equals 63, and then we can add the equations together to eliminate y. 77x plus -8x equals 69x, 7y plus -7y equals 0y, and 63 plus -63 equals 0. Awesome! Now that we only have one variable in our equation, we can solve. We'll rewrite this as 69x equals 0, and divide by 69 on both sides to find that x equals 0. Next, we can substitute 0 for x into either of our two variable equations. How about this one? -8 times 0 is 0, which leaves us with -7y equals -63. And dividing both sides by -7, we find that y equals 9. That's two variables down. We're almost there. To find the value of our final variable z, we can substitute 0 for x and 9 for y into any of our three variable equations and solve. Let's use the first one. We'll substitute the values and simplify to find that -9 plus z equals 0. And when we add 9 to both sides, we can see that z equals 9 as well. Nice work! So the solution to this system of three equations is the three-dimensional point with coordinates 0, 9, 9. Let's try another. Once again, we're going to solve this system of equations for x, y, and z using elimination. But right off the bat, I noticed something a little different about this problem. I don't see an x in our first equation, so let's approach this one a little differently. If we can eliminate x from the second and third equations, then we'll be left with an equation that only contains y and z, just like our first equation does. Let's see how this works. First, we'll line up the second and third equations. To eliminate x, we'll multiply the entire top equation by -4 and the entire bottom equation by 3. Then we'll add together the equations. We're left with 7y plus 22z equals -197. Great, now we can use our new equation and our original first equation, negative 6y minus z equals 26, to eliminate another variable. If we multiply the entire bottom equation by 22, we can eliminate z. We'll add these equations together to get negative 125y equals 375. And now that we only have one variable in our equation, we can solve. Dividing both sides by negative 125, we find that y is equal to negative 3. Now let's solve for the other two variables. We can start by substituting negative 3 for y in either of our two variable equations. Let's use this one. Negative 6 times negative 3 is 18, and when we simplify this equation, we find that z equals negative 8. Finally, we can use this equation to find the value of x. We'll substitute negative 3 for y and negative 8 for z, and simplify. Simplifying further, we find that 3x equals negative 3, which means x equals negative 1. So the solution to this system of three equations is the three-dimensional point with coordinates negative 1, negative 3, negative 8. Great job today, and thanks for watching. I hope this video has given you the confidence to master this skill.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.